give this question your best shot. A triangle has two sides with lengths of 6 and 11 respectively, which the following cannot be the perimeter of the triangle. Perhaps what some of you tried to do is set up a right triangle with these leg lengths. So you get 6 and 11, and then maybe you did the Pythagorean theorem. So you would do 6 squared plus 11 squared equals c squared. So you would do the square root of 36 plus 121. You'd square root that, you would get 12.5. And then you'd add these together and you get like 29 or 30, and then maybe say that D is closest. But there's a couple problems with this. Number one, we want to find what cannot be the perimeter of the triangle. So this actually seems like 39 or 30 or 29, whatever this turns out to be closest to, is a perimeter of the triangle. It's possible. The second issue is nothing in the problem said that this is a right triangle. So we can't even assume that it's a right triangle in the first place. So what do you do with this question? Well, this is a question that's actually not that bad once you know the trick. And the trick is the triangle inequality. I've gone over this in the SAT Math Bootcamp, but I'll review it again here. When you have a triangle with two sides that have been defined, so let's say 6 and 11, and when you're trying to find the third side, we'll call that C. As this angle between the 6 and the 11 varies, you're going to vary the length of this third side. And I'm not going to go into the long derivation here. I'll leave a link in the description to the triangle inequality video. But basically what you find out is that this third side C has got to be greater than the difference of the other two sides, but then smaller than the sum of the other two sides. So in this case, our third side has got to be greater than 6 minus 11, or 11 minus 6, so greater than 5. And it's got to be smaller than the sum, so it's got to be smaller than 17. So these are all our possible values for our third side. And if you think about it, if I then go ahead, I know that 6 plus 11 is 17. So my perimeter then, if I add 17 to both of these, if I add that third side to my other two sides, my perimeter has got to therefore be between 22 and 34. And notice these are not greater than or equal to or less than or equal to signs, so 22 and 34 are not included. So I could have 23. I could have 24. That would be if my third side C were 7. I could have 27. I could have 31. I could have 33. All of those are possible perimeters given the possible third lengths of my side. However, 22 does not work because in order for 22 to be the perimeter, this side would have to be 5, and we've determined that the third side C has got to be bigger than 5 at the minimum. So that means A is my answer because my perimeter cannot be 22 based on this triangle inequality. To learn more about Reason Prep's SAT, SAT subject test, and ACT video courses, go to reasonprep.com/enroll, and you can find the link in the description below the video.